G'day Internet, and this is the last episode of the Improving Your Secure Code Review Skills. It's been a while since the last episode, and so I thought might as well finish it up. The reason for that is I don't really enjoy making the videos. I don't get as much out of them as I hoped I would. And I have no desire to be a YouTuber. So I thought this might be a good time to just wrap the series up. But before we do that, I wanted to go back over some of the items that we've covered. So I think the first item is the importance of practice and building the experience by doing secure code review. So I've gotten a number of questions around the content in terms of wanting to see other languages, wanting cheat sheets of the commands, supporting blog posts explaining the items a bit more in depth. I'm not going to do any of those things. I'm finishing the series, and the point of the series was really to show some examples of how you can engage in these activities, but ultimately growing in this capacity generally requires some effort. There's a few good blog posts. You can just type this into Google to find some resources, but the concept of deliberate practice, where you put aside time during your week or your month to practice something for the sake of the practice and the building of skills. So you're not really focused on the outcome. You're not necessarily focused on, I'm going to find a bug, I'm going to get the CVE. It's simply working on the process for the sake of becoming better at the process. And I find that can be very integral to growing within secure code review, because it does require a lot of knowledge of the language, knowledge of the environment in which it's running, knowledge of the different bug classes. And sometimes you need a bit of creativity because not every bug class has been discovered. And so if you're finding a new bug class, you might have to get creative. The other thing I sort of wanted to cover is the use of tools. We haven't really used a lot of tools in this series. Tools can be great. I think they're really about saving time. So ultimately, the output of the tool has to be, doesn't have to be, but should be reviewed by a human to ascertain the accuracy of the findings. Some tools are prone to false positives, some more than other. And so it's sort of the job of the analyst or the researcher to look at it. And then lastly is, I tend to come at secure code review from the view of a researcher. So I'm not trying to find every bug in the code base. I was really just trying to find enough to get code execution usually. That tends to be my primary goal. And obviously someone who's doing code review from I want to close off all vulnerabilities in the code base. The approaches and the level of attention to details might be a little different. And that sort of finishes off the things I wanted to discuss. But lastly, there was one thing in episode, I think it was episode 6, where we looked at Exponent CMS, I did suggest that there were 3 other exercises that you might want to try with the same bug. So I'll cover those off. I didn't see any submissions, so I won't be giving out any prizes for that. One more thing before I go into that. I have had some questions about training. I do offer training, although it's more aimed at security research. So quick introduction to finding bugs, does cover code review, does cover fuzzing, web exploitation, binary exploitation. You can find that at training.justanotherhacker.com. I'll link that down below. I will be running classes virtually and probably in person in 2023. So keep an eye out for those. And I'm also looking to establish a new course for offensive code reviews, which I'm also hoping to launch next year. So 2023 should be a good year for some training. Any information for that will be on my social media, so Twitter, Mastodon, and the website training.justanotherhacker.com. So with that covered off, let's have a look at the Exponent CMS. You can go back and look at that. The actual analysis of the bug in one of the previous episodes. Just wanted to quickly just run through it. We basically have this bit, I think it was an install file. Yeah, page. I think it was page request page. Wasn't escaping. I wrote it to the config PHP. Yes, it's under this. Yes, post SC. Sorry, this is. Yep. So it checks the config PHP, sanitizes that, and then writes it back into the config. And the config lives here. And I think we used the SMTP port to change it from 25 to something else. And the 3 challenges were, what's an approach that could sort of go undetected, because you are stomping on the config file. So someone might notice that the configuration has changed. And then the other question was, what was a way to exploit this that didn't require 2 sets of executions? And if that doesn't make sense to you, you really should go check the previous episode where I explained it, to avoid the escaping thing. So that was the second question. And then the third question was, if you were to exploit this without being able to escape, so you could only have normal characters, no apostrophes, no new lines, no backslash, could you still do it? So those were the 3 questions, and we'll look at those in turn. I'm just going to start a web server in the back end, so we can prove this. So the first one I want to cover, which is actually the easiest one, I don't really need to go through the exploitation, is here. You can define a database name, a database user, database password, and a host and a port. So even without breaking out, simply the fact that you can override the database configuration and point it to an internet-facing database that the attacker controls. So, you put localhost.com here. You can leave the username and password as was. What's going to happen is when you then go to the website, it'll reach out to the attacker's database. So the attacker defines, an administrative user, non-password. You can then log in to the web panel, and presumably there is a file upload here, or you can, modify the template. Like in the case of WordPress, once you're logging in as an administrator, you can usually alter some PHP file, upload a PHP file, get code execution that way, or through some of the content in the database that you control. So that's a very easy way to get code execution without needing to break the encoding. So you don't have to break out of this at all. You just redefine the values, connect to the attacker's control database, log in as admin, upload a file. Again, this is likely to get detected because suddenly the database has changed, but the attacker has code execution on the machine at that point. They're probably not care. And the second one I wanted to cover of these was sort of undetected now. There's a good chance you could do that with some of these simple ones like SMTP port, right? Chances are it is 25 or the SSL version. Or you can pick one that has a sort of a hard code name. I don't know if anyone would change the organization name or the CK editor, etc. But we can also access it and see there's a fair few things that come out in the output. Let's make this big. CSS. So we see here in the JavaScript definition, it defines a few things such as the theme, SEF URLs, versions. It's also interesting to see that it does actually leak the local file path as well. But you can basically change any of these, or you can actually see here that it says Exponent CMS, a powerful, flexible, intuitive web solution. We see here that the organization name and site title basically matches what we're seeing there. So you could have used any of those values. So you do one GET request, record the value that you want, you stomp on that value, do it twice, so you get code exec, and then after you have code exec on the machine, change it back to what it originally was. Then hopefully nobody noticed. If you do that programmatically, that's very fast. And the last one to notice, I don't know, I'm not going to go too deep into this. These are all normal single quote values. However, this bit here called current config name is not. And if memory serves me right, let me go back into the index here. I think there was the get profile is handled differently. It goes maybe it was another step configuration, and I think that one lived in. Actually, let's just core subsystems, AXP settings. I think we'll just do the current config name comes from profile. The profile and can either come from the GET request, or we can specify. A simple way to test that is to we can say that's great. I cheated and prepared one earlier. So this one's using the Pages app, SC, current config name pawn. And that might have been for a different reason. I think we need to post this actually. Yeah. Okay. What was the next page for you? Is that process the okay. Yes, that's right. It has to be saved, otherwise it doesn't update. Just I can recreate this actually. Back. Transmission. It's not. There we go, the escaping. And so we see that unlike the previous one where we were escaping the we're escaping out of the escape due to the replace. We don't have to do that in this case. It just straight up just put a double quote to escape out of the double quote. Yeah, so that's the explanation of the three challenges. One is you overwrite the database and point it somewhere else. Two is you leak an existing value and replace that back into the config after you get codexec. And then the third one is just find a different variation of the same bug and make it easier. And that concludes this series. Again, a reminder, if you think this is interesting, you want to learn more, I'm going to be running training next year. So yeah, go check out training.justanotherhacker.com for all of the details. Thanks and goodbye.